Okay, here we are. So, I just released a new version. I did 1 gigabyte page table entries. Anyway, so the with Multicore, Core 0 has more work than everybody else. So I tried not using Core 0, but that doesn't make a lot of sense because in the flight simulator, Core 0 has to draw the background. That takes some time. Then everybody gets together and Core 0 draws the initial background with the horizon line. Then everybody gets together and draws on top, and then Core 0 waits for the window to be redrawn. And some of the glitches, I think if it adjusts the size of each core's strip, and if those jump around, I think that can cause the glitches. Perhaps it misses the opportunity to get drawn on the screen. I want to get rid of, well, so I tried a version without Core 0, and after I thought about it, it didn't make any sense because they have to be synchronized at this point, and then they have to be synchronized from here on. And basically, the only way it would make sense would be if the reason that Core 0 has less available is because of Linux, and if we stopped using Core 0, then well, we would only be using it for the background and the window refresh. Basically, maybe we would let Linux have it. Say hi, puppy. Say hi. Hi. That's my puppy. Okay, so Now what? Now what? Now what? So, so the people at OS Dev are CIA spies that somehow spy on me with clairvoyance or some shit. I don't know. They're real proud of their resolution. They don't understand that I wanted 640 by 480. They seem to think I wrote my own compiler. These people are not even close to my league. I wrote a fucking compiler. I'm in a higher league than you piece of shits. They got attitude fucking always. Anyway, so let's see what God says. I didn't do any adultery. So, I guess people want TempleOS. I can talk about TempleOS. So, what can we talk about? I know what, it's not very flattering. So let's talk about Psalmody, or let's talk about this application. You can, I'm clicking the mouse on these keys. You can press the keys. I'm hitting keys. You can put notes up here. It only does one voice. So in other words, you only get one note at a time. That's the way we operate. So you can use the cursor keys. The nice thing about one voice at a time, I just did the clipboard shift insert. The cursor keys are a joy to use because you can, it's just like doing text. You can cut and paste and cut and paste. So that's a joy. You hit carriage return for the right click. I think you can right click, yeah. And I use instead of quarter note, eighth note, I use the numeric value. So 1.5 is a dotted quarter note. So if you want to make it a rest, I don't use the rest symbols. I use grayed out. That's a rest, and it goes in the center. I wonder what tie looks like. Oh, it doesn't show up. So you have to set words. Carriage return. So this is a. So once you get fast, you probably won't get fast. Okay, so I'm going to hit carriage return, set word, so you can say ham. Then you can put C. To use TempleOS, you have to know C. You have to know C and printf and stuff. So now we can save this, save as, and then press F7 and it'll give a random word. Incredibly.cpp.z. So that's F7. So now we bail out of here, go to our home directory. So it saved it into our home directory, and this is what the song looks like. So the play has a notation. It's really obvious. Octave 2, quarter note G, D, F, eighth note G, octave 3, A, octave 2, quarter note G, D, F, eighth note G, octave 3, eighth. And each note can have a word. Now this is kind of real songs don't always put the words on notes. So these songs are kind of limited. So anyway, I did a lot of songs. So this play function has the musical notation and then the words. And this is the documentation on whole note, half note, quarter note, dot, triplet. Can do measure or time signatures, sharp and flat. So you can add graphics. Now once you start modifying this, the Psalmody program can no longer edit. If you add graphics, it's not able to edit that. It'll ruin it. So the last thing you do is the graphics. I'm gonna hit. Did you know that Control D is the file manager? And I'm gonna go ahead and delete Psalmody directory. Okay, that's gone. We can look at so here's my other songs. So those have graphics. I guess I need to now that I think about it, I made my jukebox with a certain size window. I did all these songs using that size window. I wonder if I should pick a different, if it's going to be standard. Like, I don't know why I picked that size window. So if it's going to be for centuries, so sometimes we get God to pick some random code. Alt B is my, I just made a, I have 64 gig of RAM. It looks like VMware needs some time in order to allocate. this is allocating, I think, 128 meg at a time. VMware has to map the memory. The reason I'm saying that is because this is slow. It's taking a very long time to map the memory. Watch this. Now if we reboot, if we do one of our reboots, and if we say mem test, it's been mapped now. So those are a lot faster. That's just a memory test. Anyway, that's just, well, it's allocating and writing the memory. Anyway, let's do a bad code. Bad code, bad code. Oh, this is actually kind of bad code. What do we got here? One of the controls. It's kind of embarrassing when you copy. So Windows has a message passing elaborate scheme where they have child windows and stuff. When I was first getting started, I was going to make child windows like Windows, and God said not to. So the way TempleOS works, there's only one window per task. So what you do for child is you say, you make a pop-up. I should know better. So you don't have child windows, you have pop-ups. And when you make a button, here's some buttons. Okay, let's look at that, the code. So the buttons are done with text widgets. This is a, you have to move the cursor around, and this is, the $ commands are bracketed with $ for start and end. And there's a 2-letter code. Text center X is a flag. There's the tag. Down here is a button with a tag. And this is left expression. We don't have child windows. We have, if you need help making these, Control L, and then we say we want a button, press me. Okay, so we just made a button right in our program. Now, as a matter of fact, you can convert it to text. Control T toggles plain text, kind of like ASCII, or kind of like HTML and the source code. Anyway, now watch this. You can do Control Shift T and it toggles one element. So Control Shift T, Control Shift T, that maybe you're putting text into a quotation. Control Shift T. So Control T toggles the whole thing, and Control Shift T does one at a time. So the control, the control L, the way you remember that, text widgets. Let's say you want to do a color, foreground, red. Now control T, there's a red there. Now we can say control shift T. Uh-oh. Let's try that again. Oh, there's red. What happened? Okay, control shift T. There's red. Okay. I don't know what happened. Anyway, maybe I don't know. Control shift T. So so these buttons, now one of the principles, it's actually necessary. Everybody else puts stuff in separate files. I don't like that. I like my resources in the same file as my code. I don't like, now as a matter of fact, jumping around to different files is actually, you don't have the screen real estate to do that. If by the time, if you open up two files, you can't see it very well on the screen, so you really do actually need it in one file. This is a form. So the compiler has this is kind of like an IDE. When you run TempleOS, as a matter of fact, like when you're, okay, as a matter of fact, when you start writing a okay, so when you do something like that, it's like we're in a compiler IDE. In other words, all the information is still available. Like main is the function. If you make a, now if you say fun rep main, it keeps track of the variables and whether they're on the stack or register variables. The reason that's relevant is because you can actually access the compiler records. So when you make a class, okay, so we just made a class. Guess what? All the symbols go into the hash table, the hash symbol table. There's a class student. So how can, now, believe it or not, you can make your program access the compiler records. What you do, if you know, okay, we'll make a you can search the hash table with hash find needle table mask instance. Okay, needle is the table. Now fs is their current task, and this is where you tell it if you want classes, if you want to search for classes, functions, or what. So hash table type class. So did we, if it returned, okay, so we found a value. So guess what? I told you it's like we're in the an IDE. All the stuff is available. All the compiler information is available. So guess what? There's even a function, class rep, and if you give it a variable, it's kind of like we're doing an example of what we're doing. Anyway, I have a variable, and it's a class, it's a H class, and anyway, so in other words, if we look up the source code, this is the source code. This class rep accessed the compiled information about the class. It knew, there's kind of a weird thing. This is really advanced, kind of a kludge. So I wanted, you can tell it any class. You can say class rep. You can you give class rep any pointer, and it will, any class. This is FS is the current task record. There it dumped the task record. So the command line is used as a as your IDE, your integrated development environment. So when you're developing, you can dump stuff. So I was going to tell you. So let's make a let's make a little program. Let's do class rep ourselves. So U8 class name. U8 is that's ASCII characters. So C. This is a hash table for class name, comma, and FS. Remember, FS is the current task. So we're gonna we want to pass it the hash table and HTT class, hash table type class. This is a bit mask. So you can search for either functions or classes or anyway. Let's print the size. How about that? Or you want to let's go ahead and it's a member list. This is there's a member list. So the class has a member list. Recently, let's see. Okay. So technically what we want to do is let's pretend we're making is how I do it. Okay, so we either found it or we didn't find it. And then temp.em equals temp. Was that crazy? Member listed head root. I recently renamed stuff. Class base class. Oh, that's the, what the hell? Okay, so it has the last one for, okay. So we are going to access the compiler record on a class. Come on. Okay, so that would be bad. Okay, so now we can say main, look at that, holy shit. So what we just did is we went through the compiler record on the class C task. So we can say main any task you want. How about any class you want? C, how about a document? There's all the member variables. Now what about the offsets? Okay, so so we can put the offset. So there's the structure offsets. So why is that head? Flags is 58. What the hell? Oh, okay. So that's a big. Now, what about the class of the? How about colon %s? How about m? Is it class? Maybe. Is that what it is? Class str. Nope, it's member class. I don't know why. So now we're going to print the name of the class. So actually, this is not. I haven't used languages for 20 years. I haven't used any new languages for 20 years. I guess a lot of languages have dynamic stuff. Anyway, so this is not very surprising. This is compiled, not interpreted. Anyway, so it gets better. You can, so once you start having this, what about if you want to fill in forms? If you want to fill in forms for when you have a record, I went ahead and did something. This is kind of crazy. So I made a meta. Member list meta star. I think we say NT. So each member I'll have to check it. Let's see what is it. Meta. So there's a let's make it green. Green, let's just print it, turn it to the same color. Okay, so now if we say it has to be, well, never mind. See, edit find text. I think this is one. Okay. So this class, this is a class, and look at these crazy format strings that are part of the class definition. The reason for this is there's a oh, we don't have that anymore. Where is that? Okay, so when you prompt for a record, the vision is kind of like when I was at Ticketmaster, there were all kinds of records, and it was command line based, and it was a mainframe. And this is kind of oriented towards that, which most people want to play video games. Anyways, I don't know. So when you hit Control F, you see this form. This form is done with a. Let's take a look at it. Find. What is it? Oh, there, we were looking at it. Okay, when you hit Control F, find, replace. Okay, so find, replace, replace. You see all those? Oh well. The good news is this is a useful procedure. If we say GS is a CPU class, and these are the members, so it knew about that. There's this crazy thing called the last class. This was a kludge. I didn't want to have to say what type of class it was. So I made a compiler feature that makes that uses the last class, the class of the last. Well, anyway, it's just for this one, not quite for this. You can do a form and pop-up form. It can figure out the class of a generic pointer. So all this stuff is dynamic. I guess modern languages do this all the time. As a matter of fact, so if we make a class, maybe you can get the size of the array. It starts getting tricky. So we're going to say main. Why don't we change this to my class? How about debug class? Debug class. And we'll say debug class student. So it printed the offset 0, the name, and the type. Now watch this. You can put, now on modern languages, this happens all the time. So basically any item you want, you can say item 1, item 2. Now, an item is a so you can fetch the value of. So there's a one value for a whenever you make up something. There's one value. There's one expression. So there's one expression. So the meta is labeled makeup and item, and I think we want temp empty value. I don't know what it is. $%X. No, it's not value. User data, okay. Well, that's kind of. Now that's an interesting point. Okay, so the string for makeup, the address of the string 1 and 2, you can see there's where those items were. So this is really powerful, but you're probably not going to use it. You know, there's a lot of things like that in like functional languages and stuff. They're like powerful, but really you don't use them very often. Anyway, so by the way, the when you're doing a format string, this is what you do for if you want to prompt. We might as well do it, huh? You want to do a pop-up form? How about S? Okay, so pop-up form address S. How about that? And then let's say dump S. Okay, so oh, we got %S. Obviously, I forgot how this works. Do you have to have a colon? I guess you do. I don't remember how this works. Oh, it has to be a data item. Oh, it gets really complicated. Okay, so Control L, data item. What is it? It's a string. You might think it's a string, but it's, yeah, I guess it is. I guess. String, format string, name colon %. 29S. Length. It can figure this stuff out. Anyway. Okay, so you have to enter a widget. And you want carriage return. Carriage return. Okay, now we do it. Okay, now we have a name and address. Barry Davis, 8144. Now I hit escape. Oh, it crashed. Okay. Whoa, it's still there. Okay. So it filled in the form. It filled in the record. It's 0 terminated. I do believe they're 0 terminated. Of course they are they not? What? Oh no, I guess they're not. Okay. Well, whatever. You can play around with it. There's various ways to anyway. So for example, you can do a cursor movement. Comma 33 cursor movement, comma 33. Now when we do it, now notice they're spaced out. So it just moved the, you can put a button, you can do, okay, so that's, the business. That's how you do business stuff. I have a feeling these games are what it's going to be used for, not business. It's really a toy, so I don't really know why I did business stuff, but it's there. When I was in high school, I made character graphics. There's no reason to do this. It makes animation cute, but there's no reason to do character graphics. Anyway, so I don't know. What do you want to see?